Stefano is currently the Eleanor Seeley Professor, visiting professor at Caltech. He is a scholar whose research encompasses both the philosophy of science, in particular the writings of Karl Popper and Thomas Kuhn, and the history of science, where his far-reaching interests include the scientific revolution, Johannes Kepler, who I believe you'll hear about today, and the history of astronomy, cosmology, and mathematics. He has held visiting positions at the universities of Padua and Pisa, as well as been an associate research scholar at the Italian Academy for Advanced Studies in America at Columbia University, as well as faculty at the School for Advanced Studies in Lucca. In keeping with his diverse research interests, Stefano Gattei has published broadly on a wide array of topics, including books on, let's see if I get this right, Critique of Uncertain Reason, Introduction to Karl Popper, The Uncompleted Revolution of Thomas Kuhn. Now, one problem, if you run to buy them and read them, I believe they're in Italian. The English titles that he wrote include Thomas Kuhn's Linguistic Turn and Legacy of Logical Positivism.
Yes.
That's what he meant.
Yes.
And Karl Popper's Philosophy of Science, Rationality Without Foundations. So without further ado, it is a pleasure to introduce Stefano today. His talk will be the hidden message of the engraved frontispiece of Kepler's Rudolphine tables. Thank you.
I'll be talking about images and the role of images in early modern scientific works. Images accompanied books almost ever since printing was invented. But usually engravings, those were the images of the day, engravings, engraved title pages, engraved frontispieces, or simply diagrams at some point used to be added to embellish the book, to ornate the book, as a form of decoration of learned, in most cases, learned decoration of the book. But there was a point in time, a period in time, after the publication of Galileo's Sidereal Nuncius in 1610, for a couple of decades, up until the trial of Galileo in 1633, and after, for a couple of more decades, in which images were used to say what was not possible to openly state in print. So images were aptly used by a number of authors, Galileo included, and his competitors included, to say or to call attention to things, and in some cases to state, as I was saying, what was forbidden to state openly with words. So we shall go through a number of instances of this, and we shall focus, of course, on a very special case, which is the engraved frontispiece of Kepler's Rudolphine tables, published in 1627. This is Kepler's last major work. Kepler died in 1630, and this was the crowning achievement of his career as an astronomer, and so this work deserved an appropriate frontispiece, and indeed it's one of the most beautiful and rich frontispieces of this kind. So we shall start with an example. This is John Bayer, the Uranometria, 1603, so before the publication of Galileo's Sidereal Nuncius. This is a book about astronomy, of course, a book about constellations. And you have a number of standard elements in title pages, in this case, of this kind. So you have, of course, the title of the book and the author at the center. Then you have these two important personifications on the two sides. On the right, your right-hand side is Hercules, the first student of astronomy, and then on the left-hand side is Atlas, the first teacher of astronomy. Then we have Apollo, representing the sun. You see the rays emanating from his head. And then Astrea, representing the moon. And then Cybele, representing Earth. This was a classic kind of engraved title page, in which classical elements were used to ornate, to decorate the book, including these few words here. In Greek, they say oudeis eisito agiometretos, which means no one should enter here if it doesn't know geometry, calling attention to the fact that astronomy was part of mathematics. And this is the motto that is traditionally is known to have been on the entrance of Plato's Academy in Athens. As I said, these are learned decorations. They deal with the content of the book, but they do not add anything to the content of the book. So much so that in this case, for example, the same author used and the same publisher used the same block, because blocks were quite expensive, so they were used and reused many times for different works. So you see the same structure as the previous title page, with Atlas and Hercules and other things representing, for example, the author of the book and so on, but for two different works. And you see that this is the original one, and then it was scraped, and a new title was added. You can actually see this E here, which surfaces here. So it is exactly the same word block used twice. Again, these were very expensive items. There's a work by Descartes, for example, in which there is a famous engraving, and the engraving is repeated some 20 times in the book, throughout the book, and in the end you see a break in the wooden block. So used so much that it eventually broke. Then, at some point, these title pages and frontispieces changed. This is Christoph Scheiner, who was a Jesuit and an astronomer. And this is 1619, so 9 years after the publication of Galileo's Sidereus Nuncius. You may know that in the Sidereus Nuncius, Galileo announces his telescopic discoveries, that the moon is very much like the Earth, that the Milky Way is made of a number of different stars, that, most importantly, Jupiter has 4 satellites. And later on, with the telescope, Galileo discovered sunspots. Scheiner thought he was the first one to actually discover sunspots. So they struggled for a number of years about the priority over the discovery. And so there was actually a battle going on between Galileo, on the one hand, and his pupils and his students, and the Jesuits of the Roman College in Rome, about the priority over the discovery of sunspots, and also the interpretation of Galileo's telescopic discoveries, pro or against the Copernican theory. So this was such a new and different frontispiece that a number of captions had to be added in order to explain to the reader the meaning of these images. So on the top left here, we have a blind man groping in the dark. So hands alone can do things, but they cannot accomplish anything. The mind and the arm need to work together. On the right-hand side, we have a man without arms, and so he can think, he can theorize, but he cannot do anything. So without hands, the eye, that is the mind, is useless. So experience is not sufficient for establishing the truth, and reason must be supplemented with experience. This is what we would now call the epistemological meaning of these images. And then, since this is a work about optics, oculus, that is the fundamentals of optics, we have optics at work. So we have a camera obscura on the bottom left corner, projecting an upright image. That was a a mistake on the side of the engraver. Then we have a system of lenses used to turn the image upside down. And then we have the telescope, of course, here. So it can allow us to overcome hills and mountains, but it may also modify what we see. We are not sure that what we see through the telescope is exactly how things are. So this was without mentioning Galileo, this was a criticism of Galileo's discoveries, or the use of these discoveries. So we cannot entirely rely upon the telescope. So the evidence we get from a telescope is not enough to make us change our mind about the structure of the universe. This was the underlying idea. Hence, and this is written in bold characters, sublimitas secura and humilitas gloriosa. That means we have to keep humble and not demand too much from ourselves. We have to rely on the scriptures and keep humble on about what our achievements. This is Galileo's reply to that work. This is the title page of the Assayer, 1623, one of Galileo's major works. And again, you can see it's quite a standard title page, very much like the ones we saw at the beginning, but it has some interesting elements. So first of all, we have the symbol of the Barberini family. In 1623, Urban VIII, who is the same pope who would later sentence Galileo to house arrest after the publication of the Dialogue in 1632, he used to be a good friend of Galileo. And so Galileo took the chance that a good friend of his got elected to the papacy, so he immediately dedicated his work to him. So we have the bees here, the three bees, and the tiara at the top. So the book is for the new pope. Then on the bottom we have two telescopes representing Galileo's chief claim to fame, and the symbols of the Lincean Academy, or the Academy of the Lynxes. Galileo was elected member of the Academy of the Lynxes, which is the oldest scientific academy in the world, which was established in 1603 by Prince Federico Cesi in Rome and lasted just, say, 20 years, but anyway. And Galileo was elected a member of the Academy, and this book was published at the expense of the Academy of the Lynxes. But what is more interesting about this title page are the two figures on the right and the left-hand sides. So we have mathematics holding a mirror sphere. This is the mathematical part of astronomy. And natural philosophy, that is physics, representing the physical part of astronomy, of course. And these two personifications are on the same level. As I said at the beginning, astronomy was regarded as a branch of mathematics. The idea was that astronomy provided mathematical models for the structure of the universe, not actually true description of the structure of the universe. What Copernicus was providing, allegedly, was not a new description of the structure of the universe, but a new mathematical model that made computation easier. And this interpretation of Copernicus' work was made possible by the fact that Copernicus' work, the De Revolutionibus, published in 1543, when shortly after Copernicus' death, had a short preface, unsigned preface, which everybody thought was by Copernicus, and it was not. It was by a Lutheran theologian, Andreas Osiander, claiming that what was in the book was just a mathematical hypothesis, not a physical hypothesis. Okay. Galileo here claims very clearly that mathematics and physics are on the same level. What he is going to provide is not merely a mathematical description, but a physical description of the actual structure of the universe. And this is the famous frontispiece for Galileo's Dialogue, 1632, the book that got Galileo into trouble, by Stefano della Bella, the engraver and a good friend of Galileo's. So we have three persons here, three people talking to one another. And who are these people? In order to make things clear, we have their names. So this is, this is Aristotle. This is Ptolemy. You see his name here. Also, it's you can recognize him from his robes. And who is this third guy? We read it's Nicolaus Copernicus. But it doesn't look like Copernicus. Indeed, this is the standard iconography of Copernicus. As you can see, he's a thin man, no beard, whereas here Copernicus is represented as quite a fat man with a beard. If this guy resembles anybody, this is actually Galileo, not Copernicus. So Stefano della Bella represented Copernicus or Galileo in the clothes of Copernicus, claiming in the image, not in the words, because officially the book presents the Copernican hypothesis and the Ptolemaic and Aristotelian hypothesis on the same level. And in the end, Galileo officially yields to the Ptolemaic hypothesis, but Stefano della Bella calls attention to the fact that Galileo is actually defending or siding with Copernicus against Ptolemy and Aristotle. So much so that after the trial takes place in 1633, after the trial, in the Latin edition and later on in another edition of the same work, we see again the standard Copernicus represented here. No longer Galileo. So there's no mention of the engraved frontispiece of the book in the proceedings of the trial, but it's quite significant that they changed it after the trial. Okay, so this is just to give you a very brief idea of how images mattered for a book. We tend to look at these books nowadays in exhibitions or in collections, and we see the image and simply give a look at them and possibly say, oh, how nice, and then turn the page. We should pay more attention to images. They complemented the whole argument of the book. They said something more than what is actually we can actually read there. And indeed, my next example, on which I will spend the rest of my talk, really is an image that speaks volumes. This is, as I mentioned at the beginning, the beautiful in folio frontispiece of Kepler's Rudolphine tables. This is the title page, in which we can see a number of interesting elements. So the book was published in 1627, so 26 years after the death of Tycho Brahe. And still, Tycho Brahe's name appears more prominent on the title page than Kepler's name. And Kepler is the author of the book, not Tycho Brahe. Why? Because Kepler had to rely on Tycho's observations, and his heirs had censorship right. They still held the copyright for those observations. So they demanded that Kepler put Tycho's name on the title page more prominent than his own. And something more. There are three versions of this title page. In the first one, which is this one here, we can read somewhere here the word emendavit. That means that Kepler corrected Tycho's data. This was not very much, the heirs of Tycho didn't like this very much. So they demanded that Kepler change the title page by deleting this word and a few other things. So he was forced to do that, otherwise he wouldn't have the permission to print the book. So he changed the title page, and in order to state his role, because he had actually corrected Tycho's data by the famous Kepler's 3 laws, which he devised. So it was not Tycho's laws, it was Kepler's laws in 1604 and 1619. So in order to state his authorship, his role as the author of the book, he added this beautiful engraving. And still the heirs didn't like it. They suspected there was something going on. So they demanded an explanation of this image. What is that? So Kepler asked a friend of his, a poet, Johann Baptist Hebenstreit, to write a long poem describing, it's 500 lines, the toughest piece of Latin I have ever translated, because it's Baroque, because it wants to appear as saying something is not really saying. So it's a partial presentation and description of this image, based on Kepler's hints. But there is much more in the frontispiece than we know from the poem. So let's take a few steps back and try to understand what's the hidden message of Kepler's frontispiece. This is a page from a map, a beautiful map from Blau's Atlas Major. And there, this is Dania, Denmark, and there we have the Isle of Hven. In the 1570s, the King of Denmark granted this island to the most famous astronomer of the time, Tycho Brahe, and he built his own observatory there. Uraniborg, the city or the castle of the sky. Then, after a few years, he built a second observatory. He was Stjernborg, the castle or the city of the stars. And this was an underground observatory, which was quite something at the time, totally unprecedented. And Tycho Brahe was actually the lord of this island. And indeed, Tycho's most famous biography is titled The Lord of Uraniborg, and he acted like one. So much so that after he left, they destroyed everything because he did not leave good memories of himself. Anyway, so let's have a look at these observatories. This is Uraniborg, as we know it from the Atlas Major, Blau's Atlas Major, and also from Tycho's own works. Blau, by the way, was a pupil of Tycho's on the island for a number of years. So this is the main observatory, another view of the same building. And this is Stjernborg, the underground observatory. So we see there are 5 crypts, each containing a different instrument. And then there was a room below this mount here. This was the entrance to the observatory. This was the only heated room in the observatory, and this is Tycho's study and where he rested, where his assistant rested, and where he worked on the data he was collecting. This is another map of the same building, and we shall focus on this room here, because this was Tycho's museum, so his kind of Hall of Fame. And this is what we now have of these observatories. So practically nothing is left, since, as I said, everything was destroyed shortly after Tycho left. And this is the hypocaust, so the underground room on which we shall talk, about which we shall talk. So these are drawings we get from Tycho's works. So this was a square room, and on every wall there were portraits of 2 astronomers from the past. So there were in total 8 astronomers, and these are the 4 couples. So we have Timocharis and Hipparchus, Ptolemy and Albatani, King Alfonso and Copernicus, of course. And the last two were, of course, Tycho Brahe and an unknown Tychonides, someone, may possibly one of his sons or one of his assistants, who in Tycho's mind was going to take up his work and continue it. Most interestingly, on the ceiling of this room was a representation of the so-called Tychonic system. Tycho offered a new structure for the universe, which was in between Ptolemy and Copernicus. So in the Tychonic system, Earth was still at the center of the universe. The moon was orbiting the Earth, and the sun, of course, was orbiting the Earth, but all other planets were orbiting the sun. So you had a kind of compound movements of the planets orbiting two objects, the sun and the moon, and the Earth at the same time. And on the wall in which Tycho's portrait was painted, there were balloons coming out of everyone's mouth, and from Tycho's mouth there was these words, quid si sic, that is, how about that? What do you think of that? So he was pointing at the ceiling of the room, so he was pointing to his own Tychonic hypothesis, and he was asking the other astronomers, his fellow astronomers from the past, what do you think of that? He was not really asking for their opinion. He was saying, look, I'm good, right? I got the real structure of the universe, which is in between. Copernicus was not right, Ptolemy was not right, Aristotle was not right. I came up with the true structure of the universe. Quid si sic, which was quite arrogant, we would now say. But, I mean, he was a man of very, he belonged to one of the noblest families in Denmark. He was very rich. He was the best astronomer of the time. He was a king at the time of that small island. So he had, he think he could do that. And now we come, this was just a kind of preface to our talk. We see how that self-representation mattered for Kepler's own frontispiece. We still have a preliminary sketch of this frontispiece. You can see there are a number of similarities, but there are also a number of differences. I will not dwell on that because, for reasons of time. I just call your attention to Tycho Brahe here, and here, and here. The same man is dressed in two different ways. Again, the heirs did not like the fact that Tycho was represented here as in his everyday clothes. He wanted him to be represented in his noble robes with his chain and so on. Anyway, so this is the frontispiece, and as I was saying, it really speaks volumes. And we shall go and see that each and every small detail of this image really has a precise meaning. Nothing is there by chance. Oh, so each and every element is a part of a larger picture with a precise meaning. So let's start with the floor of this structure. This is a temple, the temple of Urania. Urania was the goddess of astronomy. And this is indeed a compact history of astronomy. As opposed to standard representations of the sky, the stars are not represented at the top, but they are represented at the bottom, on the floor. So on the floor we have stars and astrological symbols. This is a 12-sided, the shape is 12-sided, representing the zodiac, and we have a number of astrological symbols and stars representing the sky. Because the sky is actually the foundation of astronomy. Astronomy is based on observations of the sky. And indeed, as we learn from the poem by Hebenstreit, the columns represent observations. So there are different kinds of columns, as you may notice. The ones on the back represents the observations of ancient astronomers. So we have a Chaldean astronomer there with a Phrygian cap here, using his fingers to measure angular separation of the stars. These were very rough observations, not very precise. And so these kind of observations are represented by crude trunks with no capitals. You see there are different columns, and the ones on the back, the most ancient observations, are represented by crude trunks, wooden trunks with no capitals. So very rough observations. Then we come to the columns on the forefront. On the right-hand side, we have the column of Meton, as we get to know from the name at the bottom of it. It's a rough brick column, and with a capital in the Tuscan order, very basic capital. And then Metonic cycle, it was a very ancient form of calendar, and this is a reference to Kepler's own works on the reformation of the Julian calendar. Galileo too, but Kepler wrote a lot about the Gregorian calendar, and he was trying to push for the reformation of the calendar to be accepted in Protestant countries as well. It took more years to be accepted in Northern Europe than it was in Southern Europe. Also because the new calendar had the name of the Catholic Pope, so the Protestants didn't really like it. But anyway, so this was Meton column, and the first reference to one of Kepler's major contributions. On the other hand side, we have the column of Aratus. His name there, again a rough brick column, a capital in the Tuscan order, an armillary sphere which is related, I won't go into the details about that, but it is related traditionally to the name of Aratus. Yes, and yes, I said about the capital in the Tuscan order. And then we progress through the centuries and come to the columns in the front. And we have the first full figure of an astronomer represented here. This is the column of Hipparchus. His name there. Again, a rough big column, a capital in the Tuscan order. And we have his catalogue of fixed stars. So Hipparchus is offering his own contribution to his fellow astronomers, his own contributions to astronomy to fellow astronomers. And there's another tablet he's holding, which merely says test, and I guess the meaning is testamentum. That is, I offer this as my own legacy for my own contribution to astronomy and my legacy to my fellow astronomers. And the celestial sphere, which is again related to Hipparchus. Opposite to that is the column of Ptolemy. This is the first really interesting with an epistemological meaning associated to it. So we have Ptolemy, and you can see that he's seated at a table. He was a kind of armchair astronomer. He was not observing the star. He was offering mathematical models for the universe. So he's represented in his Eastern robes. He was from Alexandria, but he's seated at a table doing computations. And his work, the Almagest, the Megale syntaxis, is in front of him. And the book covers actually a portable quadrant, stating the fact, calling attention to the fact that his computations came before actual observations. The quadrant was used to perform observations, of course. And most interestingly, there's a picture here there's a geometrical diagram here, which might seem any geometrical drawing. In fact, it is a representation of Ptolemy's so-called Ptolemy's theorem, which plays a key role in the construction of the table of chords and hence in the trigonometrical computations that were the key to astronomical computations. So this is just to call attention to the fact that each and every detail of this engraving tells something. Yes, this is Ptolemy's theorem. And of course, we have at the front a diagram with eccentrics and epicycles, which is the main claim to fame of Ptolemy. He came up with a way of correcting the Aristotelian picture by adding eccentrics and epicycles in order to account for the number of anomalies in the observations that could not be accounted for in the Aristotelian picture. Again, we have a rough brick column, a capital in the Tuscan order, and an instrument, in this case the astrolabe, which is associated with Ptolemy. And then we come to the central columns, which are the most important. They are placed at the center, in the forefront of the temple. On the left-hand side, we have Copernicus and his column. On his lap lays a copy of his work, De Revolutionibus, published in 1543. And then another work which actually this is quite interesting because this work, this collection of observations of Regiomontanus and his pupil Walter was actually published 1 year after the death of Copernicus. So how come Kepler associates Copernicus with this work? Because we know that Copernicus owned a manuscript copy of this work. And Kepler knew very well about it. We have a brand new column, not a rough brick column. We have a capital in the Doric order. We have a cross staff and a triquetrum, so-called, the two instruments Copernicus used for his observations. By the way, Tycho owned Copernicus' triquetrum, which was given to him as a gift, being the most famous astronomer of his time. And yes, this is actually you see this is Copernicus, which does not resemble the Copernicus we saw at the beginning. So there are two traditional iconographies of Copernicus. This is the second one, the less important, if you would. But it's this way of representing Copernicus comes in other works as well. This is another example, 1611, the Tabulae Rudolphinae, and later on in Lorenzo Crasso's short biographies of important people, we have this fictional representation of Copernicus, which very much resembles this one and the one we have on Copernicus, on Kepler's frontispiece. Opposite to Copernicus is the column of Tycho Brahe. You have his name. He is representing his noble robes. One of his main works, the Astronomiae Instaurate pro Gymnasmata, published in 1602 and edited. Tycho had died the year before, in 1601. This was published thanks to Kepler, who edited this work. So it placed there just to call once again attention to the fact that Kepler had a role in that. We have a perfect column in a most beautiful capital in the Corinthian order. This is to please the heirs, of course. And then two instruments devised by Tycho, the portable sextant and the portable quadrant. Very interestingly, we see the words quid si sic, the same words we found in the hypocaust, in the underground room in which Tycho was working in his observatory on the Isle of Hven. Kepler never was there. Kepler got to know Tycho later on, but he knew about that from Tycho's own works. And he knew that in that hypocaust, Tycho represented himself as pointing to the ceiling, pointing to his own Tychonic hypothesis and asking fellow astronomers, what do you think of that? Of course, this is a very different context. So he uses the same words in a very different context. Here, Tycho is talking to Copernicus. The two never actually met, of course. I mean, this is not a historic representation. This is Copernicus died in 1543. Tycho Brahe was born in 1546. But anyway, the two are talking to one another. So Tycho is pointing to the ceiling once again, and we shall see that there's a Tychonic system here, just as if there was a Tychonic system in the hypocaust. But Copernicus is not really impressed. He's seated, and he's having this gesture with his hands. He's saying, well, yes, your hypothesis, my hypothesis, more or less are the same. We can account for observations more or less in the same way. So why should I accept yours as an improvement on mine? And why should someone like Kepler, which we shall see is represented here, side with Copernicus and not with Tycho, if the two systems bore more or less the same rigorous predictions about the positions of the planets and so on? We shall see this in a moment. But as I was saying, the context in which the words are used is very, very different. And there are other representations of Tycho uttering the same words. He was, as I said, quite arrogant to portray himself like that in his own observatory, and a number of his contemporaries did not lose the opportunity to mock him a number of times about that. This is the iconographic source for this representation of Tycho. So the engraver is actually using a self-representation of Tycho from one of his works. This is one of the most famous and well-known instruments devised by Tycho, the mural quadrant, which was in Uraniborg. And actually there are two Tychos in this picture. So this was the actual instrument. This is Tycho here, reading the instrument. There was light coming from this hole there, and he's reading the instrument and telling his observations to two of his pupils, two of his assistants. And this was a blank wall. So at some point he asked an artist to fill the wall with something, and of course, what better than a self-representation? So he once again represented himself performing some observations. So we have two Tychos here. And this is really the iconographic source for this. We have the same clothes. You may notice the chain here, or the order of the elephant, the most important honor you could receive from the King of Denmark, and of course Tycho got it. And we have the same cloth, the same gesture, so this is actually the iconographic source for this representation of Tycho. This was always to please Tycho's heir. So he was portraying Tycho as he himself portrayed him. So no one could complain about that. At the top, he is pointing at a representation, as I was saying, of the Tychonic system. At the center is the Earth, and the Sun is orbiting the Earth, and the other planets are orbiting the Sun. But interestingly, in this representation of the Tychonic system, the Sun and the Earth are represented quite close to one another. So we might say that due to perspective, the Tychonic system collapses into the Copernican system, because the Sun and the Earth almost coincide at the center of the universe. And the circular parts for the planet become, due to the perspective, elliptical orbs. Okay. And we now move to the top part of this engraving. At the top we have an eagle representing the the Holy Roman Emperors, Rudolf, Matthias, and Ferdinand II, who actually funded Tycho for a number of years, and later on Kepler, who was appointed court mathematician, imperial mathematician actually, to complete Tycho's work, and to which is was the compilation of the Rudolphine tables, named after Rudolf II, who actually started the work. From the beak of the eagle, we have a number of golden coins falling. Thanks to the support of the emperors, scientists could work. So we have a number of coins falling. There are 3 coins at the feet of Tycho here. One here, others are falling here on the table, and very, very few coins on the table of Kepler's. This was a way of saying that Kepler was really lamenting the fact that he was never actually paid for his own work. He was promised a stipend that he got very, very seldom. He actually died on the way to see the new emperor to claim for his own past payments. He died on the way in 1630. Anyway, so this is, of course, a due representation of the supporters of research, astronomical research. Then we have, of course, this is the Temple of Urania, the goddess of astronomy. This is a representation of astronomy, of Urania, crowned with stars, and offering a laurel to the author of the book, that is to Kepler. And this, the source of this representation of this Urania crowning Kepler, we also find in Kepler's own works. You see, it is exactly the same thing. This is a diagram representing the second law, which Kepler discovered in 1604 and published in 1609, and he immediately realized it was very important, so he had this, the goddess of astronomy crowning him for that. Okay. Then we have 6 personifications, 3 couples, representing the optical part, the mathematical part, and the physical part of astronomy. We have here optics. I'll go very quick about this because I don't have much time left. More important is this one. This is a telescope, so no mention of Galileo, but of course this is a clear reference, implicit reference to Galileo. And as you may see, this is the only goddess that is turning to the others. So the optical part of astronomy is turning to the mathematical and the physical parts of astronomy to ask for their help for the interpretation of the telescopic observations. Kepler was among those who claimed that mere observations were not enough. We had to know how the telescope worked, something Galileo never really understood, but Kepler did. And we have to integrate observations with mathematics and physics in order to provide a real support for the Copernican hypothesis. Then we have logarithmica. Holds 2 sticks, one twice the other. So this refers to the fact that Kepler understands logarithms as Euclid did, as a sort of, Euclid did not know logarithms, but Kepler understood logarithm as ratios among numbers, and Euclid did exactly the same thing in the 5th book of the Elements. And we have here a representation of the so-called Keplerian logarithm. So this is 1, this is 2, and this is the Keplerian logarithm of 1/2, and it's exactly represented here. Nothing is here by chance. It's very precise, very precise. Kepler was actually the first to use logarithms in astronomy. Against his own master, Michael Mestlin, that claimed that all computations were done by hand at the time, and he claimed Kepler, of course, was introducing logarithms because they allowed to save a lot of time, and Messlin replied in a letter saying, astronomers should not be afraid of doing calculations, so you should not use shortcuts. Anyway, closed eyes representing the effort of making these computations. Then we have trigonometry, with a compass, of course, and a representation of the second law, so what we now call the second law for planetary motions. This is actually a picture from the Rudolphine table themselves. And then we come to the third part of astronomy, the physical part of astronomy. This is statics. This is a representation of together the second and the first law from another works of Kepler's, so the Epitome Astronomiae Copernicanae. And then lastly, magnetics. William Gilbert's work on the magnetics was published in 1600, and Kepler appealed to this work in order to explain the non-uniform motion of the planets around the Sun on elliptical orbits. Okay, and this is the explanation for the acceleration and deceleration of the planets in their elliptical orbits around the Sun. And I now come to the last part, which is the basement. So on the very front, once again to please Tycho's heirs, we have a representation of Hven, once again, with Uraniborg here, Stjerneborg here, exactly as it was in Tycho Brahe's work. So paying due tribute to Tycho's achievements. Then we have references to the printing processes and the difficult composition of the work. But the most interesting part is the last two plates on the left-hand side. This is one of Tycho's hair, possibly that Tychonides we saw represented in the Hypocaust. So he's pointing to a number of books at the top and to the man in the next plate, which is Kepler. So he's calling Kepler to his depth, to Tycho's observations. This is a way of calling attention of the reader to the fact that whatever Kepler did was made possible by Tycho. Without him, without his precious books of observations, this would never have been possible. Okay, and lastly, Kepler. How do we know this is Kepler? Because there are a number of his works here. And then we have the coats of arms of Bohemia and Prague, where the book was, he started working on the book in Prague while he was the imperial mathematician at the court of Rudolf II, and then the coats of arms of Upper Austria and Linz, where the book was eventually completed. Then we have Kepler's main works, the Mysterium Cosmographicum, his work on optics, the New Astronomy, in which he published the first and second law of planetary motions, and the Epitome. And then, of course, a few golden coins. But we shall come back to that. So look at this self-representation of Kepler. He is looking to the reader. He's staring at the reader. He's not looking at the other people in the engraving. And there is only one precedent to that. In 1543, the same year in which Copernicus published his book on De Revolutionibus, another major scientific work was published. It's Vesalius' De Humani Corporis Fabrica, the first modern book on medicine and anatomy. And this is a self-representation of Vesalius on the book. And as you can see, he's not looking at the picture, he's looking at the reader. There was no question back then who was the author of that book. As we can see from the title page of Vesalius' book, Vesalius' name is there, is prominent, and he's represented here among others. And so there's no question about the role of his role as the author of the book. But once again, he calls attention to his main role by looking at the reader. Twice, in the picture I've just shown and in this self-representation on the title page. He's performing an autopsy of a woman, by the way, which is quite interesting, but that would take us on to another different story. But so this is Vesalius. Look at his hands, position of his hands, and look at the instruments on his table. We have an ink pot, we have a candlestick, and a candle. So let us compare these two pictures with that picture in mind. So for Tycho's heirs, Kepler is representing himself as a humble pupil of Tycho. He is seated at a table, just like Tycho's assistant. We have the same table and the same cloth. We have the same candlestick we have in Vesalius' book. We have an ink pot. We have the same cap. So he's the humble assistant of Tycho. We have notes and computation. This is again a reference to the fact that he had no paper. He had to write on the tablecloth. He had no money. He was asking for money to do his research. Anyway. But unlike Tycho's assistant, he's not writing what Tycho is saying. His pen is not in his hand, he's on the ink pot, meaning that his work is over. He has accomplished something. And just like Vesalius, he is looking at the reader, thereby calling attention to the fact that he is the main character in this temple of Urania, in this compact history of astronomy. And lastly, in front of him on his table, there's a copy of the dome of the Temple of Urania. That means that astronomy has been made possible throughout history by a number of contributions by different astronomers, including Copernicus, Hipparchus, and including Tycho Brahe, of course. But Kepler is the one who came to the completion of astronomy. He is the author and designer of the top of the temple, of the dome completing the temple. He is the architect of the temple who completed once and forever the history of astronomy. Indeed, we have a letter of Kepler to a friend of his, a fellow astronomer, saying, Tycho has all the material for this new building. He has the bricks, he has the wood, he has beautiful windows, but he lacks an architect who is able to assemble all the material and make up a new building. And this is actually the role Kepler demanded for himself, even though he had to deal with Tycho's heirs. And that's it. Thank you.
Can you show the eagle again, please?
Sure. The eagle. A number of slides. I have to go back. Here it is. Yeah.
Over there on the right wing, is that like a cross? Is that any significance?
This one here?
No, right up on top, it looks like a cross. Move up, take the right away, right that light.
Oh, this is a symbol of the Holy Roman Empire.
Yeah, well, I was wondering.
Yeah, it's the scepter and the crown representing the Holy Roman Empire, and the eagle is the symbol of the House of Habsburgs. Rudolf II, his brother Matthias, and then Ferdinand were all three Holy Roman emperors belonging to the same house of Habsburg. So this is a reference to them. Yeah.
Excuse me for a sec. Just a small interruption in the questions. I just heard from Patty that there's a car running actually in the parking lot. This car is yours. You may want to go out there. It's a BMW 7X0B937, California plate. Anybody here? No. Okay, good. So I saw a question here and I saw a question back there. So let's start here.
How much did the people who saw that at the time of publication
We're aware.
understand it?
Yeah, that's a good question. This was for professionals. There were a number of elements that were accessible to anybody, and indeed, Tycho's heir, which were not professional astronomers, understood a number of elements here. But there were other things which were accessible only to a limited number of professional astronomers. And Kepler knew he was talking to them. This was a very technical piece of work. The whole book is a very technical piece of work. Actually so technical that a few years later others came up with simplified versions of how to use these astronomical tables, because actually the book is this thick and half of it are instructions on how to use the tables in the second half. And it's extremely complicated to use them. And so, but he knew he was talking to someone. Maybe not a large audience, but he knew he was talking to the ones he wanted to talk to. He wanted them to know what was his role in the thing, and that what kind of role he asked for himself within the history of astronomy. So not a large audience, but a very selected number of people, but the important ones, those who actually could make use of this work, professional astronomers.
Yes. Over there in the back. Yep, go ahead.
Yes. Was there any hint of any explanation of forces or reasons why things appeared as they did at that time? This is before Newton and gravity and all that. You mentioned something about magnetic fields or magnetic.
Not magnetic fields. The
observations.
The word force was not there. Kepler himself uses the word virtus, this kind of property of the Earth, for example, to attract other objects, or of the Sun to attract other things. And he explained why. We may go to that. Sorry, I really made too many slides. Yeah. In the Astronomia Nova, in which he presents for the first time what we now call the first two laws of planetary motion, so the so-called ellipse law, the planets go around the Sun in ellipses, not in circles, and the arrow law, implying that the motion of the planets around the Sun was non-uniform. So we have an accelerated motion in the perihelion, and planets decelerated as they reached the aphelion here. How can we account for that? So Kepler appealed to Gilbert's work on magnets, and he claimed that when the dipoles, which he assumed that the planets were dipoles, were aligned with the dipole in the Sun, the virtus, or what we would now call a force, was stronger, and therefore the planet accelerated here, was moved faster here. And then, when it came to this position, you see the dipole is not aligned with the dipole of the Sun, so it decelerated. So there was no mention of forces. This came only with Newton. There was no mention of gravity, but they had quite a rough idea of an explanation for that. And by the way, Kepler did not know calculus. That was, we know calculus from Newton, from Leibniz, so a few decades after Kepler. And still he was able to come up with the error law, in which you have to compute an area, the area of a triangle in which one of the sides is not straight. How did he do that? He came up with something which is very, very similar to what Newton would later do in a more rigorous terms with calculus. But he had a number of things that anticipated, in inverted commas, Newton's achievements. In history, it's always a mistake to talk about precursors or anticipations. Kepler was doing what he was doing. He had no idea what Newton was going to do, so he did not precur Newton or anticipate what Newton later did. He did what he was doing, but it's interesting to see that he did things that were very closely resembling what Newton would do a few decades after him.
When you present this, it's a sort of a revelation to us today to really grab on to the idea of how important books were. How important it was the only means of communication.
Well, there were letters, which is yeah.
But other written papers and letters and things. But it's rather astonishing for us to get back into that thought of how precious and important the illustrations being, a very important part, but just the whole concept of books.
That's right, that's right. And these books were published in very limited number of copies. I'm doing a census actually of this work, and I've seen so far some 120 copies, because there are tiny little differences in the copies. So the book, for example, comes, the first two quires of this book, each comes in 3 different versions. And you almost never find the same version for both quires. So the quires were later assembled because the books were sold unbound. That's why we have nowadays, we can see different works bound in the same volume, because it was up to the owner to bind the volume later on. And anyway, these works, Galileo, Sidereus, Nuncius, they were published in very, very few copies compared to what we would now regard as a decent print run even for a technical academic work. For example, this is published in about 200 copies. Galileo's work was published in 350 copies. They were sold out in a couple of days. So they were very precious, very expensive, especially this kind of engravings were extremely expensive, and still they were done. They were extremely important for the circulation of ideas, for the feedback. And indeed, we have different versions of the same book because the author got some feedback and corrected the work. So instead of publishing a second edition, for example, because it was too expensive, they only corrected a few things here and there and simply replaced the quire with a new quire. And so that's why it's interesting to check the differences to see the printing history of the book.
Maybe last 1 or 2 questions?
You made numerous references to the need to accommodate the Tychos family. And I think you used the word copyright at one point in your talk. Was there a system of law that encompassed something resembling modern copyright?
Not really. But it was obvious that, for example, when Kepler came to Prague to work with Tycho, the two worked together for 1 year or so, because Tycho died in 1601, Kepler died in 1600. And Kepler was not allowed to see the whole of, as he was hoping to see, the whole of Tycho's data. He was allowed to access only the data pertaining to the orbit of Mars, which was the most recalcitrant planet to obey the Copernican or Tychonic hypothesis. And so Kepler was a brilliant astronomer, was asked to work on that and to accommodate the data with the theory. It was only with Tycho's death that Kepler inherited, in a sense, as the new imperial mathematician, all of Tycho's data and his instruments. But then his heirs complained about that. They appealed to the emperor, and eventually they managed to get back all the data and the instruments. And so in order to use them, Kepler had to come to terms with them. So they belonged to them. There was no official declaration about that, no official statement, but they were by Tychos, they were his heirs, and so they belonged to them. And in order to use them, Kepler had to come to terms with them. Otherwise, they would have denied permission and he wouldn't be able to publish the work.
In all of the representations of Tycho, he has a nose. Yet, in reality, he lost that as a young man. Why is that?
Why he lost his nose?
No, why is he portrayed with a nose?
All right. He actually had a fake nose. He was wearing a fake nose. He had a silver fake nose for everyday work, and then a golden nose for important occasions. When he met with the king, for example, you could not present yourself with a golden nose, with a silver nose. Of course, you have to wear. So, if you look closely to portraits of Tycho, you notice that there is something strange in the nose. You can actually, if you know the story, you can actually spot the fact that it was prosthetic, yes. It's a prosthetic nose. So it is represented with a nose, but it was clear, and it was not known to everybody that it was a prosthetic nose. So also in his official self-representations, he portrayed himself with this prosthetic nose. But of course, here is the image is too little to underline that or to reflect that.
Last question?
I was actually wondering, and I don't know, I don't show up to a whole lot of these that aren't pertain directly to the hard sciences. How do you know the exact interpretations? Like, how do you find out that one image means one thing instead of another?
Good question. Indeed, if you read the quote I put on my very last slide, that's a quote from a nice book by Alberto Manghel, who was a pupil of Borges, and he says in that quote, more or less, that we try to connect different pieces when reading images. We try to tell a story out of a number of hints and clues we get and we know about. So we know quite a lot about this image from the long poem I mentioned. We know other things from Kepler's own letters. We can get some clues from his own works that preceded this engraved frontispiece. We know something from Kepler's friends who helped him draw and engrave this picture. And the rest is hypothesis. I try to come up with a coherent picture that fits with all the elements we have, but it's, of course, it's lastly an interpretation. It's nothing more than that. I believe it's quite a good one. It fits with what we know about this image, and it fits with the context in which this image was produced, and it deals with the problems Kepler was dealing with. So even though it is an interpretation, it cannot be more than that. We cannot have a proof that what I've been saying is the proper interpretation, but we know for a number of things that I believe it's a reasonable, plausible interpretation of the image.
It's like 90% correct.
I'm the wrong person to ask that.
You're not allowed to put numbers on stuff like that.
Oh,
I'm sorry, I don't know a whole lot about this.
I don't think there is any way of attaching any number to this. But if you ask me, since you asked me, I would say 98, but... Well, thank you very much.